Now, just to talk about this from the perspective where we are matching elements, look at your question 1 here from the 1100 tutorial sheet. So we are saying mapping a set onto another set, right? You already did sets, topic 1 or sets. So look at set A. Set A is a set of what? Discrete numbers, right? Then set B is also discrete numbers. You are given these numbers here. And you notice that there is a pattern for every case that is given. So they are saying, which of the following sets of ordered pairs represents a function from A to B? And for each pairs, state the domain and the range. So I'll get the first pair. So the first pair is 0, 1. So let me just give you an illustration of what a function really is. So this is 0, 1. That's the first pair. The second one, let me just open it from my phone. So the second one is simply this guy here. We're having a 1, negative 2. And also the other one is 2, 0. This is 2, 0. And the next one is simply a 3, 2. So this is 3, 2. This is what we are having. They want us to relate these. So we can show it nicely by simply writing the first set, the x values. So these are coordinates. They are given in the form of x, y. So these are x values. The first ones are all x values. So you have there's a 0, then there's a 1, then there's a 2, then there's a 3. Then the y values, we simply have a 1, then we have a negative 2, then we have a 0, then we have a 2. You notice that 0 is related to 1, that's what you are having. Then 1 is related to negative 2, then 2 is related to 0, and 3 is related to 2. So this is a type of function that this is a type of relation that we said is a one-to-one, and this is a proper example of a function. We said a function is a rule that maps elements from one set and to another set, and every input has a unique output. So remember how we discussed the classes, or rather before we did the classes, there are groups of functions. These are groups of relations. We said all functions are relations, but not all relations are functions. Only the one-to-one relation is also a function, because one object cannot have two shadows, right? So this is a perfect illustration of what a function looks like. If you come to question 1, number 2, Roman numeral 2, the set given is 0, negative 1, then there is a 2, 2, then there is 1, negative 2, then there is 3, 0, then there is 1, 1. So if I may, here on top, they said the domain. So the domain here is all the x values. This is the domain. The set of 0, 1, 2, and 3, that's a domain. Then the range is the output. The range of all the y values, that's simply your range. What we are producing. And don't repeat things that are, if there's any number, if there was a number that was repeating, we wouldn't have written it twice. You just write it once. A proper example is here. So on the x, you have 0, 2, 1, 3, 1. So we have 0, we have 1, we have 2, then we have 3. You don't get to write 1 twice. You just write it once. This is what you have. Then this side, you have a negative 1, then there's a 2, there's a negative 2, then there's a 0, then there's a 1. There's a 1 down here. So you notice 0 is related to negative 1, then 2 is related to 2, then you have 1 is related to negative 2, then you have 3 is related to 0, then you have 1 is also related to 1. So you see that this is not a one-to-one function. This is a rather one-to-many, because there is one that is mapped to two things. So this is called a one-to-many function. relation. This is just a relation, but not a function. This is not a function because there is no way one number here can produce two things. Are you guys following on the part for question 1? Christophe, this is your tutorial sheet, Christophe. You understand the matching that we're doing here, right?
Yes.
Okay. So we're just still basing everything on the definition of what a function is. That's what we are simply saying. Yeah, so the same would apply for the other one as well. We're just making arrow diagrams here. So your number 1, 3 will still be the same. So I will just go straight ahead and write the domain. So the domain is these x values. The x values, so there is 0 because it was 0, 1. Then there was a 1, 0. Then there was a 2, 0 and a 3, 0. Already you are seeing that 3 things are producing the same thing, right? Is it? Because you're having what? You're having 0, 1, 2, 3. 0, 1, 2, 3. Literally, there is 0, 1, 0, 1, 2, 3. Then this side, y. On the y, there's only 1. Then there's a 0. So 0 is the only one that's mapped to 1. Everything else is producing a 0. So this is simply many to 1. This is a perfect illustration of many to 1. That's the name of this type of relation. And it's not a function. Though it's not a function, it does have the domain. This part here is the domain, the x values. This part here is the range, the numbers that we are getting. Yeah. So even if something is not a function, it will still have x values, which is the domain, and y values that are being gotten, which is simply the range. Yeah. So that's what you do there on the first one. Then the last one on question 1 is still the same. We still have to match things. So if you may look at it, this is given as what? They said 0, 2. The last question there on number 1, 3, 0. Then you have 1, 1. So we have the x values, there's 0, there's 3, then there's 1. So there's 0, there's 3, then there's a 1. The y values, there's a 2, there's a 0 and a 1. 2, 0 and a 1. So 0 is giving us a 2, 3 is giving us a 0, 1 is giving us a 1. So this is a proper function. This is a function and a relation. So it's a relation and a function, and it's a one-to-one function. And this is simply our domain here. This is your domain, and this is your range this side. So this is simply your answer to number 1. This is how we can order these pairs to form an arrow diagram so that you see the picture on how these are related. Any questions, guys, here? John, is this okay? Okay, that's good if this is okay. So aside from this, we then went forward. So this was just emphasizing the whole definition of what a domain is. To say domain is the values that x is going to take, then range is the values that y is going to take. Now, for something to be a function, like your question 2, look at your question 2. So question 2, they were asking to say which of the following equation defines y as a function. Like the first one is a function. This is a quadratic function. The second one is a straight line. It's a function, a straight line. This here is not a function because y is not the subject of the formula. Same applies with this. This is not a function because y is not, it's a function in terms of x, but it's not a function when it comes to the y variable that they're asking about. So they want it to be specifically in terms of y. So the only ones that are functions in terms of y are simply 1, number 4, then number 5, and also number 3. The other two are not functions because they are not in terms of x. So we are basically saying for something to be a function, a letter to be a function. So your question question 2. In case you're wondering what this is going to be, why we're saying the first one is a function, this is a function, this is a normal quadratic function in terms of x because it's well defined. So this is a quadratic function. We discussed this. And the next one is a linear function. This is number 4. Number 4 is y is equal to 5, meaning it's just a line on 5, a horizontal line. Then I said the ones that are not functions, there is number 2 and number 5. So number 2 is x is equal to y squared plus 5. Now we are saying this is not a function in terms of y, it's a function in terms of x, because if you try to solve it, so you may be tempted to make y the subject, and if you do so, this is going to give us the square root, but plus or minus x minus 5 is equal to y. Because if you are finding the square root of something, let's say 4, if you're finding the square root of this, you should be ready to say y can be plus or minus what? 2, right? So now, if you're making y the subject, you have something that looks like this. Now, we are not at liberty to decide whether this can either be negative or positive. So, because we're having options, a function is a rule that doesn't give you options. If the function is like the first one, there is no option here. If I ask you to say, what is the value of y when x is equal to 2? Everyone is going to get 8 because you put the 2 there, then you say 2 squared plus 4, you solve it, you get 8. There is no option as to whether someone can get a plus or minus 8. So that's the reason why this guy is not a function, because it's not a one-to-one expression. From the square root, the answer can either be negative or positive. That's the main reason why this guy here is not a function. The same applies with the one at the bottom here on number 5. For something to be a function in terms of y, meaning y should be the subject, like here, y is equal to the square root, the positive square root of x minus 5. It's very much defined. So, hope you're okay with this. Any questions, guys, here? Or number 2, they just want you to identify which of the following is a function in terms of y. Any questions here, Christopher? Any questions here, or Vanveka?
Vanveka.
Okay. Okay, so any other questions, guys? Daniel? Any questions here? John, are you getting what we're saying? Okay, so we are moving to part 3. Now, before we even go to part 3, let me just, for the purpose of those who missed the introduction, Harry, I'm not really conversant with what you're okay with. So just a minor recap, just in 5 minutes, I just give you a recap of everything that we did previously. So we discussed classes of functions. The first type are linear functions. We said linear functions, they all look like this. They are straight lines. The highest power of x is always 1. So a perfect illustration is like f of x is equal to, let's say, 2x plus 4. And these are always standard. So John, the best way you can know the domain and the range is just to master these types, because for linear, the domain and the range are always equal to each other, unless otherwise, which is only applicable to the 1120 guys I explained in the video I forwarded in the morning, when the domain is restricted. But for a linear, it's always the same because it can go anywhere. All numbers are welcome when it comes to the linear function because it's just a straight line. Then the second type, we discussed quadratic functions. Those functions that look like this, bx plus c. It can either face up or face down. So we say the domain is all real numbers all the time unless they're restricted. So the domain is all real numbers all the time. X is all real numbers all the time. Then if your function looks like this, if your function is facing, so the range is, if your function is facing up, your range is y values greater than or equal to the value of 4 minus this the y component of the turning point. This is if your graph is facing like that. Then if your graph is facing down, y is going to be less than or equal to this guy here. This is the simplest way I've found on how you can be getting the range of any quadratic function. So it depends with the coefficient of a. You know, to say here the coefficient of x squared is greater than 0, here it's less than 0, right? So it really depends with what you are given on quadratic functions. Then we later went forward and discussed rational functions. We said functions that look like this, that are in the form of a over b. A perfect illustration is, let's say 2 then x plus 3. We said you always solve the down part. It should never be equal to 0. So the domain is simply the denominator. The domain is all real numbers, but the denominator should not be equal to 0, right? So like this one here, the domain will be all real numbers, but x should not be equal to -3. You solve this guy. So when you solve x plus 3 is not equal to 0, you can take the 3 this side, it will give you this, right? Yeah, so this is how we get the domain of a rational function that looks like that. And to find the range, we said for you to get the range, you always first of all have to get there are two ways, there are two methods. So method 1, we said you can just get what we call the horizontal asymptote. And the horizontal asymptote in this case is simply the coefficient of x on top, since there is nothing. So the horizontal asymptote, so this is all real numbers, but not the horizontal asymptote, which is 0 in this case. When it's like this, when it's bottom heavy, when there's no x on the numerator, but there's something that has x at the bottom, the horizontal asymptote is always equal to 0. So we're saying all numbers but not 0. And if they are of the same degree, let's say you have 3x minus 4, then you have, let's say 5x plus 7. If there's x on top and there's x at the bottom, the horizontal asymptote is always the coefficient of x on top divided by the coefficient of x at the bottom. So y is equal to 3 over 5. So in this case, the range will be all real numbers but not 3 over 5. We don't allow the horizontal asymptote. All numbers are allowed but not the horizontal asymptote. Alternatively, method 2. Method 2 is where you get the inverse first. You get the inverse of that function. This is applicable for rational functions. You get the inverse first. Then the domain of the inverse is going to be the range of the original function. That's what you basically have. Yeah, so that's what we discussed. And I should have mentioned, I think I did mention number 4, which are radical functions. So radical functions are all functions that look like this. They are in a square root. So meaning their domain is that the inside part should always be greater than or equal to 0, because we can never accommodate a negative outcome in the square root. It should always be positive, right? Yeah, so this is the domain. Then the range is also fixed. This is always going to be that. So let me say f of x. So here we have f of x, so that we have this. So now if you look at your question number 2 is very much straightforward. They are saying given that the function f of x is this, find f of 5. So this is simple. You did this in high school. They've given us a function. The function given is f of x, which is equal to x squared. So we're having x squared minus 4x, then we're having a plus 2. They want us to get the first thing, which is f of 5. So if we get f of 5 here, meaning we put 5 wherever there's x, this is a 5, then this is a 2. This will give us a 25 minus 20, then plus a 2. So this will just end up being a 5 plus a 2. This will be a 7. I hope this is okay. Is this okay, guys? Is this okay? Patience, are you able to see the screen? Patience, you're able to hear me, right? Okay, good. So we can proceed to the next part. So I'll try to do the next part. So which part here of question 3 looks hard? It's the same thing. So what we've done for number 1 is what we do even here. We put -3. Then here we'll put, wherever there's x, we put a -3. So if you put -3, you simply get, you put -3 squared, then minus 4 times -3, then plus a 2. This will give us a 9 plus 12 and plus a 2. This will simply give us what? This is simply going to give us a 23 if I'm not mistaken. So here you get a 23. F of A, nothing will change. They are not even trying to confuse you here. They just want you to cement your whole idea of a function at a point. So the function f of x was given to be the same thing, which is x squared minus 4x then plus 2. So when they're asking for f of A, meaning just put A wherever there's x. So this is what you get, then plus a 2. The next part, they want you to get what is f of A plus B, meaning wherever there was x there, we're going to put A plus B, then squared minus 4, then A plus B, then plus a 2. So this can be simplified to be A squared plus 2AB plus B squared minus 4A minus 4B, then plus a 2. Then here we try to look for like terms. There are no like terms, so we just let it be at this same particular point. So that is your number 3, 4. That's what they have given us there. They want us to get f of A plus B, meaning wherever there is x, we replaced with A plus B. Then the other one, the next one, they're asking us to get f of A plus f of B. So meaning we already have f of A here, if you remember it. So we just have to get f of B. F of B will be B squared minus 4B then plus 2, implying that f of A plus f of B is just us solving, putting this f of A expression here, which is A squared minus 4A then plus 2, plus f of B, this guy here, which is simply B squared minus f of B then plus 2. So we try to gather like terms here. If there are any, there will be A squared then plus B squared, then minus 4 minus 4B, then this is just plus a 4. So this, you just leave it here. This is just what they want to see. F of A plus f of B. Hope this is okay. Any questions up to this point? Anyone with any questions, guys, here? Is this okay before we do the last one, the last part of question 3?
No questions, sir.
Okay, so if there are no questions, I can just run you through question 3. Question 3 is also the same, except this is a bit interesting because they want you to get f of x plus h, then minus f of x, then divide your answer by h. So they want us to get, this is what they want us to get. So question 3.6, they want f of x plus h, then minus the original function, then divided by h. So f of x plus h, first of all, f of x is already given. It's x squared minus 4x, then plus a 2. So f of x plus h, meaning we are putting x plus h wherever there is x. This is what we're going to do. Then plus a 2. You can simplify this to be x squared plus 2hx, then plus h squared minus fx minus 4 that. This is plus 2. Then this is equal to, there are no like terms here, so I'll just leave it to be the way it is. Now they want us to find f of x plus h minus f of x, then divide everything by h. So we'll just make replacements now. We already know what f of x plus h is, this part here. So we'll get the whole thing. Yeah, so I'll just get the whole thing and replace it there. 2hx plus h squared, then minus, I'm having a minus 4x, then minus 4h plus 2 minus the original function. So we put it in brackets because we need the minus to affect everything. Down you just have an h. This is what the substitution is going to look like. So I hope you're okay. We just said where there is x, we had put x plus h. Then the other one is just f of x, which is the original function, this part here. Then now we're simply going to get the expansion of this. The first part is not changed. Then the second part, we just affect it with a negative. Everything is affected with a negative. Then down, you still have your h down. So you notice some things that are going to cancel out here. So this cancels with that. The 4x cancels with that. The 2 cancels with that. So you'll notice you only remain with everything that remains. I mean, we'll have h. This is what you're going to get. On top, h is common, so you factorize it. 2x plus h, then minus 4. Then down you just have an h. You can cancel this. So your final answer should be 2x plus h, then minus a 4. This is your final answer. Now this may not make sense now why they are asking you to do this. But there's a portion in calculus where it's called differentiating using first principles. We'll use this same formula here that you've done here. So this is under functions here. They just want you to show how it simplifies, and this is what we are getting. Just to instill this whole concept of finding f of something. So that's what they just want you to understand. To say whenever they say f of something, meaning put that something wherever there was x in the original function. So f of x was that. When they ask for f of x plus h, meaning we're adding or rather replacing x plus h wherever there was x in the original question. So this is the illustration to your part 6 of question number 3. Hope that's okay. Is everyone okay with this? Any questions? John, is this okay? You have any questions? Any questions, guys? Or this is okay? Okay, seems there are no questions. So we...
Sir.
Yes, Macnon.
Okay. I think my question is like, I want to know the part for first principle for dy dx there. This for now or do it later?
I will do it later. Here is just this formula, this whole substitution formula. Here, just learn how to simplify it. We are going to do the application under calculus later on.
Okay, sir.
Yeah, so they just want you to take note of the substitution, and most people make mistakes when we reach calculus because of the same. I don't know how they tend to forget that if we say they are okay with solving f of 5, f of negative 3, but then when they use letters, people get confused. It's the same thing. If you're able to find f of 5, you can still get f of a and also get f of b. So this is what they're just trying to instill in us. Yeah, so for now, it's just a substitution. That's all. So I want to explain this part here before I'll skip number 4, because number 4 is under piecewise functions. I didn't teach them. So I wanted to do a recap on everything that we covered, like things like getting the domain, the range, those things. Yeah, so I'm going to add on something to what we covered last time. We did how to get or how to determine whether a function is odd or even. So I'll answer number 5, then we'll go to number 6 and 7. Then, yeah, this will be enough for today. Then we'll come back to composite and then getting the piecewise function sketching like question 4 later on. Yeah, so today let me do 5, 6, and 7. So how do we determine whether a function is odd or even? So I gave a description last time to say an odd function is a function whereby if you put f of negative x in the function, it's the same as you getting negative f of that value that you put there. I gave an illustration to say you can use any number provided the domain is allowed by that function. How do you know the number is allowed by the domain or it's part of the domain? When we put the number in the function, it's not going to give us error on the calculator or in our solving. It has an outcome. So you can use any number. We're just saying even -1 should be the same as f of -1, something like this, meaning the function is odd. Then we say the function is even if f of negative x is the same as f of x. Yeah, so what I meant here is that if you put f of -1 and put 1 in the function, when you are getting two answers and they are the same but having opposite signs, where one is positive, one is negative, meaning the function is odd. But if you are putting the two numbers and one answer is positive and the other one is also positive, meaning the function is even. But if the two answers you are getting are not the same in magnitude, they are totally different. Let's say you find a 2 and a 3, meaning the function is neither odd nor even. It doesn't fall anywhere. So like your question number 1 here, I'll just replace anything that I feel will be okay. So this is f of x is equal to x3, then there's x4, then plus a 1. So I just put anything there. Yeah, so I'll put, let's say 1. You decide to use 1. Why 1? Because 1 can give us a proper outcome, right? If I'm going to put f of -1, and I'm also going to test f of 1. So if I put f of -1 there, that's a 3. I put a -1 there, 4, then plus 1. This is giving us a -1. Down, I'm just getting a 1 plus a 1. This is giving us -half. Then if I put 1 in the same function again, I have a 3. This is 1 to the power that, plus 1. This is just 1 over 2. You notice that the numbers are the same, but the signs are different, right? So the function is odd. That's how you identify. So if the numbers are the same, but the signs are different, meaning your function is what? Is odd. If everything is the same, meaning it's even. Then if they are totally different, it's neither even nor odd. Yeah, so that answers our part 1. Then if you want to get part 2 here we have to be careful because I cannot use -1 because the down part will be 0. So there is f of x. This is your question 6.2. F of x is equal to x to the power 4 over x3, then plus a 1. So here I can just decide to use 2 or -2. So I'll use -2 first. There's a -2 to the power 4. Then we have a -2 to the power 3, then plus a 1. This here is giving us 2 to the power 4. That should give us a 16. This here is giving us -8 plus 1. This is going to give us -16 over 7. And if you use f of 2 is equal to 2 to the power 4. Then you have 2 to the power 3 plus 1. This is a 16. This is simply 8 plus that. That's a 9. So you notice that the numbers are very much different, right? So this function is neither even or odd. So this is basically how we are going to be categorizing them. So the same applies to any function. Maybe I can try to show you for this one. This guy here, and also the last one is one that looks a bit interesting. Yeah, so but you did modulus from tutorial sheet 1, so even if they put modulus here, we should treat it in a similar way. So you have question number 6. There is 6IV. There is f of x is equal to, then there is x minus 1, 3, then plus, this is x plus 1 to the power 3. So you can use any number that you want. We can use either a 1. So we'll use a 1 here. So f of 1, this is 1 minus 1. then plus this is going to be 1 plus 1, 3. This will just give us 8. Then if I try negative 1, this is going to give us negative 1, that. This is going to give us negative 1 plus 1, 3. This will just give us negative 2 to the power 3. This will be negative 8. So you're seeing the numbers are the same, but the signs are opposite, right? So meaning this is initially an odd function. Yeah, and this was linear, so you can pick any number. There's nothing like the function will be undefined. So the same applies even for the last one. It's literally the same thing again. F of x is equal to the modulus of x, then over x. So I'll try f of negative 1. This is going to be the modulus of negative 1 over negative 1. This is 1 over negative 1. This is just negative 1 there. Then if you try to put 1 in the function, you get 1. This is just 1 over 1. This is just 1. You notice this, the functions are producing answers with the same magnitude but opposite signs. So meaning this is also an odd function. Is number 5 okay, guys? Any question on number 5? Is there anything that looks challenging there? Question number 5. Let me just so question number 5. Is this okay, guys? Christopher, miti munasova kudala hivi te? Yeah, so it's literally the same thing. So you can test the rest to see. You just put a number that will be defined or that will be part of the domain. That's basically how you do it. Yeah, so that's your number 5. Silence means things are a bit okay. So we can go to question number 6. Number 6, they are asking about the domain throughout. Yeah, so we'll start with the first one. Here I'll try to do everything so that you really understand this, because there will always be a question on domains. Yeah, so question number 6. So question number 6, we're just saying the domain. So number 1, they're just saying, what's the domain of f of x is equal to the square root of x minus 3. So you always have to know the function that you're dealing with. This is a radical function, meaning the guy in the square root must always be what? Must always be positive, right? So the domain is x such that x is any real number, provided that real number makes x minus 3 to be greater than or equal to what? 0. This can now be simplified. X is such that it's a real number, x is greater than or equal to 3. Some people will just say this is just from 3 to positive infinity. That's the what? That's the domain. So that's what we do whenever you are dealing with a radical function. Ngaparichechi square root. We try to solve the inside part. Another way, other people tell you no, instead of doing this, other people say if you have something like this, just solve what's inside. X minus 3 is equal to 0. X is equal to 3. Then get the 3, put it pakati, because you just got 3. Then test. What I mean by testing is, select any number that's before 3 on the number line. So I'll select 0. Select any number that's after 3 on the number line. I'll select 5. So if I put 0 there, the answer I'm getting is 0 minus 3. The guy I'm getting inside is negative 3. The outcome is what? Negative, right? We don't want it to ever be negative. If I put a 5, the outcome I'm getting is positive. So we want it to be positive, meaning it's from 3 up to positive infinity. That's where the domain is coming from. So this is why we are getting this. Because the inside part must always be greater than or equal to 0. It can be 0 because the square root of 0 is 0, but it can never be negative. No wonder here it's closed, then infinity is open. So that's your number 6, 6a, 6.1 I mean. So if we go to 6.2, 6.2 is almost the same. There's g of x. They only flipped this. So I want you to see the difference here. This is still going to be the same. We just say this must be greater than or equal to 0. negative x is greater than or equal to that. When you're dividing with a negative, the sign changes, right? This is going to be that, so meaning it's from negative infinity up to a 3 closed. This is what you are getting. So I hope you are seeing what's happening, guys, here. Please, if you are behind, just unmute yourself, then I'll be able to hear your comment or your question. Is this okay? John, is this okay? Okay, so we can just continue with the next part. I'm trying to do everything here on the domain so that you just confirm with me with what you got, or rather what you thought the answers were supposed to be. So here they are saying h of x is equal to 1 over the square root of x minus 3. This is what we're having. So this here is a mixture of a rational function and a radical function. So if there was no 1 on top, if it was just the square root of x minus 3, we would have said x minus 3 should be greater than or equal to what? 0, right? But then if this whole thing becomes 0, if it becomes 0, meaning our answer, our expression will be 1 over 0, and this is undefined. You cannot divide any number by 0, but you can divide 0 by any number. The answer is 0, right? So to accommodate both dealing with a rational expression and a radical expression, we're just going to say x minus 3 must just be greater than 0. It does not include 0, but just includes anything positive. Because the reason why this will come out like this is if 0 is included. Yeah, so to change this, we'll just use greater than. So this is going to be x is greater than 3, meaning the domain is just from 3 up to positive infinity, where 3 is not part. So all the numbers we can try out here should be 3 point something going above. 3 is not part of the set, because when we put 3 there, we'll get 3 minus 3, which is 0. The square root of 0 is just 0. The down part will be 0. Yeah, so we have to satisfy both cases, because this is in a rational form and again in a radical form. So to satisfy that, we have to use the greater than symbol to describe our domain, because we cannot say greater than or equal to and include 0, because this should never be 0. It should just be greater than a 0. So it's the same thing that we also do on the next one. So the next one here, we just solve the inside part. We're not concerned about the outside part, just solve the inside part. 1 minus x should be greater than or equal to 0. This will be greater than or equal to negative 1. We divide by negative, meaning x should be less than or equal to 1. So meaning here the domain is a negative infinity up to 1, then closed. That's what you have. In a case like this, we focus on the down part. The down part is the guy that can give us problems. We don't care about the top part, because if we do care, but for the first thing that we consider is the bottom part. That's the part we give most priority on. So this is, let's say, f of x. This is x plus 1, then over x minus 2. So first of all, we'll say all numbers are allowed but not 2, right? Any real number is permitted, but x minus 2 should never be equal to 0. And if you solve this, we'll get a 2. So meaning, this is like on the number line, x should not be equal to 2. We're just saying at 2, there's a hole there at 2. That's basically what we're saying. Then for the top part, we're just saying x plus 1 must be greater than or equal to 0. Because the top part can be 0, we're okay with that, because 0 divided by anything is still 0, right? No wonder we are allowing the 0 there. Then this will be x is greater than or equal to negative 1. So there's a negative 1 right here, which is closed. So now we're going like that. So where are both the numerator and the denominator appearing? In short, what's their intersection? So the intersection is from negative 1 to 2 and also 2 to positive infinity. So this will give us the domain to be closed from -1 to 2 open, union, open from 2, then to positive infinity. This is how we would get the domain when there's a combination of a radical expression in a rational form like this. Is this confusing, guys? Maknon, Nakamba Maningi, do you have questions, guys?
Sir, I wanted to put it in the other form, like the notation form, yeah. Notation form, yeah.
Oh, okay. Yeah, you can just leave it like that. So the way we treat this guy here is almost the same way we treat this guy here, except here there's no square root on top. So your number, I think let's end on here. So this is saying f of x is equal to, so they're saying f of x is equal to x minus 4, then over this. So the down part can become a problem if x is equal to 0, right? That's the only thing. So x should never be equal to 0. That's the only thing that we can think about. So x should just be, in short, it should never be 0. This whole thing should never be 0 because it will be undefined. But according to the square root suggests that x must be greater than 0. So meaning our domain will just be from 0 to positive infinity, because this thing inside will never be negative, and then this whole thing can never be 0 again because the function will be undefined. So to accommodate or support them both, we'll simply put the domain to be from 0 to positive infinity. Anything here will be allowed by the function. Any questions, guys? Here, Macnon, is this confusing?
No, it's fine.
Okay, John, is this confusing? Okay, so if this is not confusing, I'll leave it here, guys. Since our time is up, I'll continue from here. I'll make a recording tonight of the whole tutorial sheet, but we'll do it per live class so that we get to interact and ask questions. But